Hey everybody, woo, infinite video. All right, today we're doing 2-4. So it's a bit of a longer assignment. We're gonna run into a bunch of ideas today. So make sure you take good notes. Remember, you are allowed to use your notes on my tests and quizzes. So 2-4, start. Okay, so here, hold on, let me make sure I have Zoom muted. That would be unfortunate for them. It's muted. We'll just say it's muted. The graphs of 4x plus 12 equals 8 and y equals mx plus 5 are perpendicular. What is the value of m? Okay, there's a whole lot going on in this question. So we actually are starting with one of the most complicated questions. I'm actually going to skip that. We will come back to that one. Yes, this one's a little bit better. So a little bit better for starting out, I mean. The first question is really, really good, and we're going to come back to it. But okay. So remember, you're allowed to work along with me as I do this. My numbers will be different than your numbers, but the ideas are all the same. So this says write an equation in slope-intercept form of the line that, so slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So I need, oops, I drew a circle. So we need y equals mx plus b that passes through the given point and is parallel to this graph. So it passes through this point, and so if you remember, passing through this point, that means I can actually plug in x and y where they belong. So like x is -9. We still don't know m, and -7 is y, and we still don't know b. But here's the other thing we do know. It says it's parallel to y equals -2x plus 5. Well, let's just examine really quick. How do I graph a line parallel equal, so here's our line, right? If this is our line, and I want a line that's parallel to it, let me write the exact same line. Let me try changing these numbers. What happens if I change this one? Oh. Changing that number changes how steep it is. Well, two lines that are parallel have the same steepness. What happens if I change this number? So it turns out for two lines to be parallel, they just need to have the same slope. So that might be one of the first pieces of notes we write down today. Parallel is same slope. So when I see that my first line here, y equals -2x plus 5, well, remember, slope is this number. That means that it's the same in our new line too. So I could say -7 is equal to -2 times -9 plus b. Oh, well, -2 times -9, I can actually find out what that is just by multiplying, right? So -2 times -9 is +18. And then to solve for b, I'll just subtract the 18 from both sides because it's currently positive. So I'll do -7 minus 18. I get -25 when I do that. So my final answer, they want an equation. My final answer, I can write y equals -2x minus 25. Let's see how that goes. Cool. All right. Let's see our next one. Here's another one that's talking about parallel. So there's a couple things in this one. So This one has the point 1, negative 2. And it has the line y equals 1. Now, we haven't spent a lot of time talking about this together, so I wanted to make sure I included some of these today. Y equals 1. Let's see what that looks like. And then let's talk about why it looks like that. Might have happened too fast. You might have missed it because it was so fast. Y equals 1. It's just a flat line going through the y value 1. So the way that we do that, the way that we know that, every y equals just a plain number line will always be perfectly flat like this. It'll always be horizontal. The reason for that is, as I drag my point around, look what's going on here. What's staying the same all along these points? These are all these different x values, but the y value is 1. And if we go back to the equation, it says, hey, the y value is always 1. So make a prediction then. What if we had said x equals 1? What kind of line would that produce? That makes this. And let's see why. Well, if we trace a point all along here, excuse me, look. The y values are changing, but all the x values are 1. So y equals lines go that way. X equals lines go this way. Personally, I remember it as they do the opposite of what I want them to do. In my mind, y goes up and down, but the actual line that a y draws is wrong. So, okay. So if I want an equation in slope-intercept form, if possible, well, couldn't I write this in slope-intercept form? Could I say y is equal to something x plus 1? The answer is yes. If there was a number, there's a number here that I could put with x. I just gave it away because I said it. 0. If I wrote 0x, then that would work. So I could write this in slope-intercept form. I could write y is equal to 0x. Oh, but I want it to go through 1, negative 2. Well, remember, we cared about the y value. So what's my y value here? Negative 2. Let's see. They're probably going to tell me I'm wrong. Yeah. So they probably don't want me to write the 0x. And I 100% disagree with them saying that. I got quiet because I'm mad. Oh, I didn't read. The equation of the line cannot be written in slope-intercept form, and I was trying to write it in slope-intercept form. So that's my fault. Okay, makes me feel a little bit better. Let me just try one more. This time the y value is negative 3, and we're finding the parallel line. So what happens if I write y equals 0x minus 3? So they believe that this is wrong. They're wrong. That's correct to write it like that. All right. I want to get into perpendicular now. Okay. I don't want to get into perpendicular where we also have to solve for y, though, because that's going to be a little tricky. You know what? No, I'll show you guys. There's a little trick we can do here. So let's see. (4x plus 12y equals 8. And y equals mx plus 5. Okay, there's going to be 2 ideas in this one question. So be very vigilant to understand. The first thing that I want to do is I want to take this equation and I want to make it say y equals mx plus b. because that's going to be the easiest way to analyze this equation. So one of the things you might notice is that when we're in standard form, x and y are on the same side. Slope-intercept form, x and y are on different sides. So the first thing I want to do is I actually want to get the x over to the other side. So the way that I am able to move it is using solving moves. So what I do is I say, well, this is currently positive, right? So there's no sign written. So then I'll use negative to get rid of it. Minus 4x, minus 4x. And let's just carry down. Over here, the positive 4x, the minus 4x, 4 minus 4 is 0, it's gone. Over here I have a positive 12y left. Now, I need to be careful. Look at the order here. They put the mx first. Which one of those would be mx? Well, the minus 4x. So I'm actually going to write minus 4x first. And then is the 8 positive or negative? Well, there's nothing written, right? So it's positive. So I'm going to say this is negative 4x plus 8. And then, do I have my calculator? I need a calculator. So I'm not on my Chromebook. If I was on my Chromebook, I would just open up my regular calculator. Oops. Double oops. Okay. So we're going to now, see how it says 12y? We wanted to say regular y. So we're going to divide by 12. And when I do that, I distribute that divide to everything that's separated by pluses and minuses and equal signs. So I divide everything by 12. 12 divided by 12 is y. So we're good with y. 12 divided by 12 is 1, and the y is left over. Then negative 4 over 12, that's where we can, if we're not sure, we can use our calculator. So I got negative 1/3. Okay. So I can write negative 1/3 x, and then 8 over 12, 2/3. All right. Okay, so we needed to do this to talk about perpendicular. So y equals negative 1/3 x. Let's look at this. Y equals negative 1/3 x plus 2/3. Honestly, the 2/3 is not the important part. The important part is this negative 1/3. So if you remember what perpendicular looks like a right angle, right? So some people think that if you take it and you flip it upside down, that gets you perpendicular. But I hope that you can see that's clearly not a right angle right there. So it's not just flipping it upside down. What you also have to do is remove the negative or put one on. So whether or not it looks like it, I promise you, these two lines are now perpendicular. So this would have been an important note to take down about how we did that problem. But then another sticky, perpendicular. There's two words that we use for this: opposite, reciprocal slope. And I can explain what that means in more basic language. So opposite means one of them's positive, one of them's negative. And then reciprocal is upside down. So our original slope was negative 1/3. our reciprocal our reciprocal and opposite slope was positive 3 over 1. But if I go over here and I try to write positive 3 over 1, it's going to yell at me because it hates me. Although your answer is equal to the correct answer, it is not in the correct form. 3 over 1 simplifies to just 3, so I can just write that as 3. Excellent. All right, let's move on. Use the slopes of lines A and B to show that they are perpendicular to each other. Okay. So on mine, let's figure this out. So let's see. I see a lattice point there, lattice point there, lattice point, lattice point. Okay, so line A, I can pick any two lattice points and count my rise over run. 1, 2, 1. So line A, I get my slope as 2 over 1. Remember though, they're going to want me to simplify that. 2 over 1 simplifies to 2. Let's look at line B. Bop, bop, bop. Again, I'm finding lattice points. That's all I'm doing. Let's find this. Let's see. So rise over run. I can't count up. I have to count down. So that's a negative 1 then. I'm counting 1, 2. So line B is negative 1 over 2. 2, negative a half. Are those opposite and reciprocal? Yes. That means they're perpendicular. So let's see. Slope of line A is 2. Slope of line B is negative 1 half. These slopes are opposites, equal, reciprocals, opposite reciprocals. So the lines are perpendicular. Perpendicular. Good job! So I know I'm moving a little quickly. I'm trying to get to every question here, and I also want to make this video not 2 hours long. So feel free to ask me any questions on any of this at any point. You know where to find me. Now we want the equation of line perpendicular to this guy that passes through this point. And, well, okay. So let me start doing it. Well, if our original is y is equal to 3/4 x plus 1, oops, I didn't zoom. Y equals 3/4 x plus 1. Well, perpendicular, which I usually will write perp because I don't want to write all the letters. Well, perp, 3/4, we know that it needs to be the reciprocal and it needs to be the opposite. So it's currently positive, so their perpendicular slope is negative. Type an equation using slope-intercept form or using the given point and point slope form. Oh, they actually let me choose. I can do slope-intercept or point slope. Well, since they give me the point, why don't I just do point slope? Because point slope says y minus y1, or what's our y value? Y minus the y value, 8. And then our m is going to be negative 4/3, parentheses x minus our x value, negative 3. Oh, wait, I don't want to say minus negative 3. I want to say plus 3. You also could have done slope-intercept form. I could have said y equals negative 4/3 x plus b, and then negative 3 and 8, plugged in the 8 for y, plugged in the negative 3 for x, and gone through solve for b like we did on this first equation. Very similar to number 1. And that would work as well. But when I have the option, I want to do something that's going to be easier. let's see, write the equation of the a line perpendicular to this that passes through this point. They want me to type my answer in slope-intercept form, so I have to use slope-intercept form. I don't like it when they make me do one or the other, because I don't think that's fair. I think I should be allowed to pick whichever one I think is easier for the situation. All right, so I'm going to show you a shortcut now. If you remember back to this guy, we did a lot of work to find out that slope, but I want to show you the shortcut. Check it out. We wound up doing this 4 divided by 12, and it was the opposite. It wasn't regular 4, it was negative 4, and then over the same 12. If we call this standard form, ax plus by equals c, this is standard form. If you take a, but the opposite of it, so negative a, and then divide it by b, that will always give you your slope. It's a shortcut. So back to this one, if I take negative a, so 4 is a, right? So if I take negative a, let me zoom in. If I take negative a, which is negative 4, and I divide it by b, now b is negative 9. Negative 4 over negative 9, convert that to a fraction, 4/9. Yeah, it doesn't simplify. Well, the negatives cancel. So 4/9 is equal to m. It says, write the equation of a line perpendicular to this that passes through this point. Oh no. We have to do slope-intercept form? I would rather just do point-slope form and be done with it. But it says I'm not allowed to. It says I have to use slope-intercept, so. I know it's going to be y equals 4/9 x plus b. And then it says my point is negative 4 comma 6. So remember, negative 4 is x. Oops, 4/9 times negative 4 plus b. And then 6 is y. So 4/9 times negative 4 is negative 16/9. No, careful. 4/9 times negative 4. All right. So negative 16/9. Don't worry. Our calculator is going to handle all this. So I'm going to take 6 and add 16/9 to it. Since it's negative, we're going to add 16/9 to both sides. So 6 plus 16/9. Ew. But just remember, the calculator is doing the work for us, so it's okay. Like, we can deal with these yucky numbers. 70/9. So my final answer for this, I'm going to get y is equal to 4 over 9 x plus 70 over 9. So let's see. Oh, I made a mistake. Oh no. Oh, I used the same slope. My answer is parallel. Oh no. Thankfully, you're not doing this question, you're doing a different one. So I did parallel. I have to redo the whole question now. Not the whole question. I have to redo from this, instead of writing 4/9, I should have written negative 9 over 4. So I really should have done y equals negative 9 over 4x plus b, right? Because perpendicular means opposite reciprocal. I still plug in the 6 and the negative 4 like I did before. Oh, this is so much nicer. Because 9 divided by 4 times 4, the 4's cancel. We're going to get 36 here. Yeah, I don't want you just to take my word for it. So negative 9 over 4 times negative 4. I'm glad you just, yeah, don't take my word for it. The 4's cancel, so I'm not doing 9 times 4 and getting 36. Oh, can't feel. 4's cancel, the negatives cancel, we get 9. Oh my goodness. Blonde moment. Okay. So now I'll subtract the 9 from both sides. So 6 minus 9 is negative 3. So my final answer now is going to be very, very different. Negative 9 over 4x minus 3. So, very, very important that we pay attention to parallel versus perpendicular. Okay, let's see what this one says. Find the equation of the line that contains the point 5, 3 and is perpendicular to the line x equals 2. Write the line in slope-intercept form. So remember, x equals 2. Think about it. Which way does that go? Does it go straight up and down? Does it go sideways? So remember, x equals 2. It goes straight up and down. What would a perpendicular line to that look like? Sideways. So now we just need to have this say y equals a y value. Well, which y value? Well, our point is 5, 3. Which one of those is the y value? So I can write this in slope-intercept form. I can write y equals 3. I have not completed the question. Oh, I have to graph it. So y equals 3. I should just go to 3. Boom, boom, boom. I'm wrong. Let me read the question. Find the equation of the line that contains the point 5. Graph the lines. Plural. They also want me to graph x equals 2. A lot of people, when they try to graph x equals 2, they'll go to 2 right here. And they'll draw a straight up and down line. But guys, be careful. That's not the x value 2, that's a y value 2. I should have gone through this point, the x value 2, and drawn it. There we go. So that's what I get for not reading. I was like, oh, this is just like the one from before, but there was a little bit more going on. Just want to make sure OBS was still going. All right. We are actually almost done. So determine whether the two lines are parallel, perpendicular, coinciding, or only intersecting. So coinciding means they are literally the same line. We can talk about how to run into that. So let's see. Boom. All right. We need to know their slopes. Well, what's the slope of this first line here? -3. Let's look at this one. Remember, the way that we were able to do this quickly with this is we could take this as A, right? And this is B, and we just do -A over B. Negative A is -12. B is 4. -12 over 4 is -3. These are the same slopes. Now, the one thing to be careful of is the slopes are the same. That means they could be the same line. So one way we can check this is to completely solve this second one out. We can subtract the 12 from both sides. Now, when I divide both sides by 4 here, this is actually where I'm going to stop. See how this one says -3x plus 7? Is this one going to say -3x plus 7? Is 1 divided by 4 7? Since it's not, I know that they're not the same line and they're just parallel. But they could have been coinciding if they both had gotten a 7 there. Number 9. Determine whether the graphs are parallel, perpendicular, neither. Oh, well, one's y equals -8. So remember, y equals -8 goes like this, right? So it's a y equals line. Then x equals 3 goes like this. So perpendicular. Determine whether the lines are parallel, perpendicular, or neither. So now we just care about parallel or perpendicular. So let's look at these again, do a new one, go El Zoomerino. All right. So slope of this one is 5. Slope of this one, I've got a 1 here, right? So I'd say -1 goes on top, right? Negative a over b. b is -2. -1 over -2 is +1/2. Is that 5? No, so they're not parallel. Is that the opposite reciprocal of 5? Well, if you flip 5 upside down, it's 5 over 1. Flip it upside down, you'd get 1 over 5. Slap a negative on it, -1/5. That would be the perpendicular. Or if you flip this upside down, it'd be 2 over 1 with a negative. In either case, these are not opposite reciprocals of each other. So these are not parallel, they're not perpendicular, they are neither. The equation of a line is this. What is the slope of a line parallel to it? Remember, parallel is same slope. What is the slope of a line perpendicular to it? Well, it's the opposite. It's already positive, so opposite would be -9 over 8. Reciprocal. Number 12. Whoa, lots of lines. An artiste is drawing up plans for a mural. She wants to include a rectangle in her design. Explain how the artist can use algebra. Or no, what is the equation of the line that will make the figure a rectangle? Well, let's see. Snipping tool is really good for stuff like this because I want to be able to draw. So wait, is this really? Oh, they give me options. Okay, I'm like, there's a lot of different rectangles I could make. Let's see, y equals 1/2 x minus 3. So 1, 2, 3. Up 1 over 2, up 1 over 2. So here's my first line. All right, that's not a rectangle. In case you're not sure what we're looking for here, we're looking for something that is going to be the same slope as that blue line and then is somewhere else around here, because that's going to make a rectangle. So let's see. Y equals -2x minus 5. So start at -5, go down 2 over 1. It's going to be like that line. That, again, nope. -1/3 x plus 2. So we'll go up to 2. -1/3 goes down 1 over 3. Up 1, backwards 3. Oh, so that might be bad drawing. Maybe that's it. The other option is -1/2 x plus 3. You know what? I didn't need to do all this, did I? I could have just counted the slope of this blue line here. Let's count the slope. Because here's what -1/2 looks like, and it's probably one of those too. Well, if I count the slope out here, down 1 over 2, the slope of the blue line is -1/2. That tells me that I'm going to need this one, because it needs to have the same slope. The artiste can determine the equation of each side of the figure. For the figure to be a rectangle, opposite sides of the rectangle have to be parallel. I mean, what do parallel lines have? They have the same slope, right? Equal slopes. Adjacent sides that are touching, must be perpendicular, meaning they have opposite reciprocal slopes. Oops, I wrote not be perpendicular. My bad. Okay. And our last question. A construction crew will build a new railroad track which passes through the point 85 and is parallel to the one modeled by the line. What equation models the path of the new track? Ooh, I'm allowed to use point slope form. Awesome. So I already know. I see my point is 85. I already know it's y minus the y value, which was 5, equals, I don't know the m yet, but I do know it's going to be x minus the x value, which is 8. I just got to find the slope, and then we're done. So it says parallel, right? So just got to go in and count the rise over run here. So from here I go down 1, 2. I always go from right to left, or from left to right. 2, and then 1, 2, 3, 4, 5, 9. 9. 2, 9. Oh wait, but I went down 2. So negative 2 over 9. And we're done. I hope this was helpful. I will see you later.